Hello everyone. I am going to discuss about the 5 basic rules of derivative. First one is constant. The definition of constant is if y is equals to f of x is equals to c, where c is a constant, then y is equals to 0. Also, the derivative of y over the derivative of x is equals to 0, and f of c is equals to 0. To further explain it, it means that as long as the derivative is constant, it will be always equals to 0. This one, let us answer the first example, which is if f of c is equals to 1, then f of c is equals to 0. Because 1 is a constant, so it will become 0. And here is the second example. Y is equals to negative 23. 23 is a constant number, therefore it is also equals to 0. Identity rule. The definition of it is if y is equals to f of x, where x is differentiable function, then y is equals to 1. Also, dy over dx is equals to 1, and f of x is equals to 1. To further understand it, let us try to solve the first example, which is y is equals to x, y is equals to 1. Why did it become 1? Remember that the derivative of the identity function is equals to 1. Likewise, the derivative of the function in the first degree is equals to its given numerical coefficient. There is an imaginary one here. That's why it become 1. And then for the second example, f of x is equals to 1/4. The third rule is power rule. If y is equals to f of c equals to x raised to n, where x is a differentiable function and n is a real number, then y is equals to nx raised to n minus 1. Also, dy over dx is equals to nx raised to n minus 1. F of x is equals to nx raised to n minus 1. So here we have an example. So we will always remember this one. And let's just copy that. Copy. To nx raised to n minus minus 1. In finding the derivative using the power rule, just make the exponent as the numerical coefficient and subtract 1 from the given exponent of the variable x. So y is equals to, this one is n, then minus 1. X, 10 minus 1 is equals to 9. That is the final answer. And also remember to simplify it, since 10x raised to 9 is already simplified. This is the final answer already. Our fourth rule is constant multiple rule. Definition, if y is equals to f of x equals c multiplied by f of x, where u of x is differentiable function, then y is equals to c multiplied by f of x. Also, dx over dy is equals to c multiplied by f of x. And f of x is equals to c multiplied by f of x. This is, remember that in finding the derivative using the constant multiple rule, the following steps should be followed. First, multiply the exponent by numerical coefficient of the given function. And then second is subtract 1 from the exponent in the given function. And always remember that simplify your answer. So let's try to solve this one. Y. Always remember this one. Y is equals to C. Y is equals to C. Multiply. And then is to 3 multiplied by this one is we will apply the power rule if you remember that one. X 2 minus 1 and 3 times 2 is equals to 6. 2 minus 1 is 1, or you can put 1 there or not. This is the final answer. Since this one is cannot be simplified anymore, it is the final answer. Fifth rule of basic rules of the derivative, and that last rule is addition subtraction rule. Definition, the derivative of multiple functions or terms are being added or subtracted together is equals to the sum or difference of the derivative of the equation of terms. This is our formula. This is the formula that you should be following. So let's try solving this problem. Let's apply the power rule, which is the n sub 2 minus 1 plus 5x plus 1. X plus 5x. And this one will be 0 since the constant rule is also applied right here. And this one is 2 minus 1 equals 1. So you can put 1 here or not. 3 times 2, 6x. And this one will be this x will be supposed to be um, 1 is 5. And that is the final answer. Since it cannot be simplified anymore, this is the final answer.
I will be discussing additional rules of derivatives. First is the sum and difference. The definition of sum and difference is if y is equals to f of x, u of x, positive, negative, v of x, where u and v are differentiable functions, then the derivative of y is equals to the derivative of u of x, positive, negative, derivative of v of x. Let us have our first example. Y is equals to 3x squared plus 2x minus 5. What we're gonna do is we multiply 3 times 2 and then x squared minus 1, since we have a rule that the exponent shall be minus by 1. And then add 2x and then the exponent of x is 1, so 1 minus 1, and then it became 0 because negative 5 is constant. So 3 times 2 is 6x raised to 1, since 2 minus 1 is 1, and then plus 2. The final answer will become 6x plus 2. Next rule that I will tackle is about quotient rule. The definition of quotient rule is if y is equals to f of x equals to u of x over v of x, where u and v are differentiable functions, then the derivative of y is equals to v of x multiplied by the derivative of u of x minus u of x multiplied by the derivative of v of x over v of x squared. To further understand the quotient rule, let's have an example. Y is equals to x squared over x minus 1. We will use the formula that I mentioned earlier. U of x is the x squared and then v of x is x minus 1. So we will substitute it. It will become x minus 1 multiplied by 2x minus x squared times 1, since the derivative of v is 1. And then over x minus 1 squared. X minus 1 times 2x, it will become x squared minus 2x. And then x squared times 1 is still x squared over x minus 1 squared. Since 2x squared and x squared has the same exponent, we will subtract it and it will become x squared and then copy the 2x. And then we will still copy the x minus 1 squared, since we can no longer simplify it. This will be the final answer. The third rule that I will discuss is the product rule. The definition of product rule is if y is equals to f of x equals to u of x equals to v of x, where u and v are differentiable functions, then y is equals to u of x multiplied by the derivative of v of x plus v of x multiplied by the derivative of u of x. I have here the example of product rule, which is y is equals to 3x squared multiplied by 2x squared minus 3. We will use this formula that I mentioned earlier. 3x squared is identified as u of x, and then 2x squared minus 3 is identified as v of x. And then what we're gonna do is we will substitute it. U of x is 3x squared plus the derivative of v of x, which is 2 times 2 and will become 4x, and then 2x squared minus 3 multiplied by 6x, since 3 times 2 is equals to 6. And then we will multiply 3x squared plus 4x. It will become 12x cubed. And then we multiplied 3 times 6x and it will become negative 18x. And then we just added 12x cubed plus 12x cubed, which became 24x cubed. And then bring down the negative 18x. This will become the final answer since the last rule in additional rules of derivatives is chain rule. The definition of chain rule is if u of x is a differentiable function, n is any real number, and y is equals to f of x equals to square bracket of u of x raised to n. Then the derivative f of x is equals to n square bracket u of x raised to n minus 1 multiplied by the derivative of u of x. An example for chain rule is y is equals to 5x plus 2 raised to cube. The derivative of u of x is 5 because 5 times 1 is 5. And then we will use the formula that I mentioned earlier. And then we will substitute. It will become 3 multiplied by 5x plus 2 squared multiplied by the derivative of u, which is 5. And then 3 times 5x is 15, and open and close parentheses 5x plus 2 raised to 2. We can no longer simplify it, so that's the final.
Hi, I'm Clarence Trinidad, and I'm here to talk about the derivatives of logarithmic and exponential function. Um, let's start with the exponential function, which has four cases. I'm going to tackle about for the first two first, which are e raised to x dx is equal to e raised to x and e raised to u dx x is equal to e raised to x, then by chain rule times du over dx. Let's an example that can be given here for the first case would be let's say e raised to 8 dx is equal to e raised to 8. For this case, we should just copy what is being asked for the derivative for. So if it is e raised to 8, then the answer, the derivative would be e raised to 8. Another would be e raised to 100 x is equal to e raised to 100. So I'm gonna erase this and give an example for the second case, which is this one. So the example for that would be let's say e raised to 2x plus 1 dx. So to get the derivative of this, we should just follow for the case 2, which is first let's copy e raised to 2x plus 1. Then by chain rule, let's get the derivative of this, which is times derivative of 2x plus 1 is 2. So the final answer for this would be 2e raised to 2x plus 1. So now, maybe let's have another example for this. Let's say we have let's say we have 5e raised to 7x. For this, this is constant, so let's just copy this and multiply it to the x, which is we're just gonna copy this one. So e raised to 7x. Then by chain rule, multiply it to the derivative of this, which is 7. So the final answer for this would be 35 e raised to 7x. Okay. So now let's consider having the other cases, which are case 3 and case 4, which are which are a raised to x dx is equal to a a h is equal to a raised to x times ln of a. Sorry for this. And the other one would be a raised to u dx. Yeah, that's is equal to a raised to u times ln times ln of a times the derivative of u, which is du over dx. Um, so the example for the first one is simple. Let's say we have 8x dx is equal to the derivative of this. First, let's copy this one, which would be 8x, then times ln. So that's the answer for this one. So we should just prioritize for the fourth case, which is let's say we have 7 is to 3x dx. So the answer for this, or the derivative for this, would be first let's copy this, which is 7 dx times ln of 7 times the derivative of this, or by chain rule, the derivative of 3x would be times 3. So the final answer, or the derivative for this equation, would be 7 raised to 3x times 3 ln of 7. Okay, so that's all for exponential. So now let's tackle about the logarithmic function just for cases. First, let's tackle these two, which are ln of x dx. X is equal to 1 over x. The other one would be ln of u dx is equal to 1 over u times the derivative, or by chain rule, times the derivative of u, which is du over dx. For this third case, this case is already an example itself, so you might already get it. But for the fourth case, let's say we have ln of 2x plus 3 dx. So to get the derivative of this, first 1 over copy 2x plus 3 times and the derivative of this, which is 2. So the final answer for this, or the derivative of the or ln of 2x plus 3, is 2 over 2x plus 3. So that's the answer for this. Now let's tackle the last two cases. Last two cases, which are, no, not last. Oh, yeah, the last two cases, which are log a x dx is equal to 1 over x ln of a, and log a u dx is equal to 1 over u ln of a ln of a times the derivative of u, which is du over dx. Let's say we have log 3 2x plus 5 dx. So to get the derivative of this, first let's first put 1 here, then over the denominator would be is the u, which is 2x plus 5. So the next one, it would be multiply to 1 over ln of 3. Then multiply to the by chain rule, multiply to the derivative of this, which is 2. So just oversimplify it, or to simplify this, the answer would be 2 over 2x plus 5 ln of 3. Hope you understand it. Thank you.
Uh, this topic will mainly focus on derivative of secant, cosecant, and derivative of cotangent. Let's start on derivative of secant functions. Definition: if y equals f of x secant x equals secant x, where x is a differentiable function, then y equals secant x tangent x. Now let's have an example. Equals y equals secant 3x. Now we just need to get the derivative of secant, which is 3x, and then tangent x. Y equals 3x tan 3x. Since the given has the value of 3x, so the derivative of 3x is 3 times 3. So this one we just need to multiply it to secant 2x and tangent 3x. So we will have 3 y equals 3 secant 3x tangent 3x. So this will be our final answer for this example. Now the second topic is the derivative of cosecant function. Definition: if y equals f of x equals cosecant x, where x is a differentiable function, then y equals negative cosecant x cotangent x. Now let's have an example. Y equals cosecant 7x cubed plus 9x squared plus 5x minus 1. So we have y equals cosecant 7x cubed plus 9x squared plus 5x minus 1. So first we need to get the derivative of this quantity. So y equals 7 times 3 equals 21. 21x minus 3 minus 1 equals 2 plus 9x squared plus 18x minus 1 equals x plus the derivative of 5x is 5 and 1 is 0. So we have 21x squared plus 18x plus 5. So we need to get the derivative of cosecant is cs negative cosecant plus cotangent x. So we have negative c as c as 7x cubed plus 9x squared plus 5x minus 1 cotangent 7x cubed plus 9x squared plus 5x minus 1. So we all know the derivative of cosecant is negative cosecant plus cotangent x. So since we have negative cosecant, since we have negative in this quantity, the final answer is negative y equals negative 21x squared minus 18x minus 5 cosecant 7x cubed plus 9x squared plus 5x minus 1 cotangent 7x cubed plus 9x squared plus 5x minus 1. So here's the final answer. Now let's move on to the last topic, derivative of cotangent function. Definition: if y equals f of x equals cotangent x, where x is a differentiable function, then y equals negative cosecant squared x. Let's have an example. Y equals x cotangent x. Wait, I'll just get my MS Paint. Y equals x cotangent x. Since you have two values, we will use product rule. Y equals q times derivative of v plus v times derivative of u. Now, so we have the derivative of y equals to u, which is x. Y equals x. Let's have the negative cosecant squared x plus cotangent x. Since we have a negative cotangent, we need to multiply to x. So we have y equals negative x cosecant x squared, cosecant squared x plus cotangent x. Now this will be the final answer.